Recall what a perfect square trinomial is from chapter 6. Those are always of the form x squared plus bx plus half of b squared. Probably didn't notice that, right? You just knew the first and the last terms were perfect squares. So let's see if we can rewrite these so that they look like they're in this form. Because here's some examples here. X squared plus 4x plus 4. So you'll see that x squared plus 4, so that's the b, plus half of b squared. So half of 4 is 2, and so that'll be 2 squared. Yep, that's in that form. Let's check another one here. X squared minus 8x plus 16. Can I write that as half of 8 squared? So that'll be x squared minus 8x plus 4 squared, which is 16. The next one, x squared plus 6x plus 9. So 9 will be half of 6 squared, which is 3 squared. Yep. Running out of room. Well, let's go down here. X squared minus 2x plus 1. So 1 will be half of 2 squared. So that is 1 squared. And then the last one, x squared plus 10x plus 25. Half of 10 squared, which is 5. And 5 squared is 25. So, yep, all perfect square trinomials can be written in this form. And what's really great and helpful about this form, about perfect square trinomials, is that they factor to the square of a binomial. So let's factor each of those above, and I'll show you. I'll just do the first one the way we normally factor. So x squared, factors of x squared, and factors of 4, which adds up to 4x. And since we already know that that's 2 squared, let's see if 2 works. Same sign, both positive. Yep. So that factors to x plus 2 times x plus 2, which is x plus 2 squared. And so we can go directly to this form because this form is x plus half of b squared. Don't believe me? So that's the factored form. And this form up here is expanded form. Okay. So let's try the next one, the x squared minus 8x plus 4. So this is going to be x plus half of b squared. So that means x minus 4 squared. Then the next one, x squared plus 6x plus 3 squared. So that's x plus half of 6 squared, which is x plus 3 squared. And that's exactly what that will be. The next one, x squared minus 2x plus 1 squared. So that'll be x plus half of b squared. So x minus 1 squared. Yep. And the last one, x squared plus 10x plus 5 squared. So x plus half of 10 squared is x plus 5 squared, which is what those factors will be. So that's what's really awesome about perfect square trinomials. And so we're going to use that to help us solve equations. The process of writing a quadratic equation, so one side is a perfect square trinomial, is called completing the square. Usually we'll be given the x squared term and the x term, and we have to create that constant term, which is half of b squared, such that this will be a perfect square trinomial. So we're just completing that square. And the steps for doing this Step 1 is, first of all, there needs to be no coefficient for that first term. So that first term should only have a 1, or in other words, nothing in front of it, no factor, because the 1 is understood. If there is a factor in front of it, that's fine. You just need to divide it out so that there is no factor in front anymore. Sometimes that creates fractions in the other terms, but that's what you got to do. You have to do that. Then the next step is to isolate all the variable terms. So you just want the variable terms on one side, and then if there are any constant terms, move them over to the other side. Because we are going to add our own constant, which is half of b squared. And if we're going to add that to one side, we have to add it to the other side. So add the same half of b squared to both sides of the equation. And then get your factors, right? X plus half of b squared equals to some number on the other side. And then just use that square root property to solve for x, like we just talked about in the last objective. Okay, so an example here. X squared plus 8x equals 1. I'm going to leave some space here because I'm going to add my own constant, right? So first thing we do is make sure there's no coefficient for the x squared term, and that's true. Then we want just the variable terms on the left side, that's true. And then we're going to add our own constant, which is half of 8 squared. So we're going to add half of 8 squared to both sides to stay equivalent, right? What we do on one side, we do on the other side. So on the left side, we have x squared plus 8x plus half of 8, which is 4 squared. So 1 plus 16 on the right side. We know that this side perfectly factors to x plus half of b, so half of 8 is 4. Quantity squared. And on the right side, 1 plus 16 is 17. So now we can use the square root property. Square root both sides, so that the left side is just the radicand, and the right side will get the plus or minus. Square root of 17 doesn't simplify because 17 is prime. So then we just need to solve for x by subtracting 4 from both sides, so that x is negative 4 first, and then the plus minus square root 17. So that will be our answer to this equation by completing the square method. Again, you can list your answers as separate answers, negative 4 plus root 17 and negative 4 minus root 17. It just looks better this way if you're writing your answer on paper. Number 2, solve this equation by completing the square. So y squared minus 5y plus 2 equals 0. First, I look to see that there's no coefficient for the y squared, and then I want just the variable terms. So I'm going to subtract 2 from both sides. So that's y squared minus 5y, leave a space, equals 0 minus 2, which is negative 2. So I left a space so that I can add my own term to that side, which is going to be half of negative 5 squared. So half of negative 5 squared. And half of negative 5 is 5 halves. So let's square that. We got 25 fourths. So we want to add negative 2 plus 25 fourths. That means we're going to have common denominator. So I need both denominators to be 4. I'm going to multiply 4 over 4 to the first fraction. So that will be, I'll just write it over here, negative 8 fourths, that's negative 2, plus 25 fourths. So now they have the same denominator, that stays, and we can combine the numerators. 25 minus 8, which is 17. So this equals 17 fourths altogether. on the right side. On the left side, this is going to factor to the square of the binomial y plus half of b, quantity squared. And now that we have this looking like a square equals a number, we can apply the square root property to solve. So that will leave just the radicand on the left side, y minus 5/2, plus or minus on the right, square root of 17/4. And we can break apart the radicals there by the quotient rule for radicals, because we can simplify this. There is a square root of 4, even if there isn't a square root of 17. So y minus 5/2 equals plus or minus square root of 17 over 2. Now we can finish solving for y by adding 5/2 to both sides of the equal sign, so that y equals 5/2 first, and then plus or minus square root 17 over 2. And again, if you want to separate those, that's fine. And you could actually put those together over the same denominator because they have the same denominator. So 5 plus or minus root 17 all over 2 would be the simplest way to write this by hand. Then for number 3, we have another equation here, 5x squared minus 10x plus 2 equals 0, and we want to solve by completing the square. So the first thing that we need to know is that there's no coefficient for the x squared term. And there is actually, so that means we need to divide 5 from every term in the equation so that it does not have a coefficient. So that's just x squared minus 2x plus 2/5 equals 0. Then we want the variable terms to be the only terms on the left side, so let's subtract 2/5 from both sides. Then x squared minus 2x, leave a space, equals 0 minus 2/5, which is negative 2/5. So now we're going to add the same term to both sides, which is completing the square here. So half of negative 2 squared, half of negative 2 squared. So on the left side, x squared minus 2x, half of negative 2 is negative 1 squared is positive 1, equals negative 2/5 plus 1 as well. But this needs to have the same denominator, so instead of 1, I'll put 5/5. That's an equivalent fraction. On the left side, we can factor that to the square of x plus half of b. So half of negative 2 is negative 1. On the right side, we're going to add the numerators over the same denominators, so 5 minus 2 is 3. And then we can use the square root property to start solving here. On the left side, just the radicand. On the right side, then, plus and minus square root of 3/5, which I'm going to separate here. And then we can add 1 to get x by itself. So x equals the 1 first, plus or minus square root of 3 over square root of 5. We generally do not like to have radicals in the denominator, so I'm going to rationalize the denominator of this term here. Multiply square root 5 over square root 5, so that this becomes in the numerator, under the radical is 3 times 5, and the denominator, square root of 25, is 5. So that denominator is rationalized. And then if I wanted to put that combine numerators over the denominator, then I could just multiply by the least common denominator here, so that this will be 5/5 plus or minus root 15/5. And so that way I can force this to be all over the same denominator in a single term. But again, either way is fine. I'm not sure what the program is going to accept. Probably it might even accept with the square root of 3/5. I don't know if it will accept that or not. It's always better to rationalize the denominator, even if you're not going to force them into the same term here. Our last example then, we have another equation, 2x squared minus 2x plus 7 equals 0. And the first thing we need to do is to make sure there's no coefficient for the x squared term. So that means we have to divide 2 from all terms in the equation so that we have just x squared minus x plus 7/2 equals 0. Then we want just the variable terms, so let's subtract 7/2 from both sides of the equation. Then x squared minus x, leave a space, equals 0 minus 7/2, which is negative 7/2. So then we're going to add half of b squared to both sides. So half of negative 1 squared. And half of negative 1, well, that's negative 1/2. And if we square that, that's going to be positive 1/4. So negative 7/2 plus 1/4. And again, I need a common denominator for 2 and 4. That'll be 4, because I can multiply 2 here. So then that'll be negative 14/4 plus 1/4. And I can factor the other side to x plus half of b, so x minus 1/2 quantity squared. Let me just add these together so I can simplify that. So negative 14 plus 1 is negative 13/4. So let's change that. Okay, then we can use the square root property. On the left side, we have just the radicand. On the right side, plus and minus. And then the square root of negative 13 over the square root of 4, because I can definitely simplify that. So the square root of 4, let's do it over here. The square root of 4 is 2, so that definitely simplifies. And then we need to break up this square root of negative 13 to be the square root of negative 1 times the square root of 13. So that gets us I root 13. And again, it's okay that it's not a real number. It's still a solution. It's not asking us to apply this to the real world, so it's not a problem for this to be complex. So this is plus and minus I root 13 over 2. Okay. Now we just need to solve for x by adding 1/2 to both sides of the equation. And we have just x on the left side. On the right side, then, we put the 1/2 first, then the plus or minus I root 13 over 2. And again, I can put the numerators together. 1 plus I root 13 all over 2. So that looks the simplest form on paper here. If I wanted to separate those terms, that's 1 plus I root 13 over 2 and 1 minus I root 13 over 2. I could further simplify by separating the two terms in the numerator. So 1/2 and I root 13 over 2. So that those are completely separate.